Today, we're diving into a massive event that happened recently on the Sun. A few days ago, millions of tons of superheated gas shot off from the Sun's surface and traveled 90 million miles toward Earth. This phenomenon, called a coronal mass ejection, wasn't particularly powerful on the space weather scale, but when it hit Earth's magnetic field, it triggered the strongest geomagnetic storm we've seen in years. Now this time, there wasn't much disruption. Most people probably didn't even know it happened, but it served as a reminder that the Sun has awakened from a years-long slumber. While these geomagnetic waves are invisible and harmless to anyone on Earth's surface, solar storms can cripple power grids, jam radio communications, expose airline crews to dangerous levels of radiation, and knock critical satellites off course. The Sun began a new 11-year cycle last year, and as it reaches its peak in 2025, the threat of powerful space weather causing chaos grows. Since the last big storms hit 17 years ago, our reliance on technology has only increased. Recent studies suggest that hardening the grid could lead to $27 billion worth of benefits for the U.S. power industry. Caitlin Durkovich, a special assistant to President Joe Biden and Senior Director of Resilience and Response in the National Security Council, said at a solar weather conference last month, "It's still remarkable to me how many people and companies think space weather is Hollywood fiction. This danger is far from hypothetical." In 2017, a solar storm turned ham radios to static, just as Category 5 Hurricane Irma was ripping through the Caribbean. In 2015, solar storms knocked out GPS in the U.S. Northeast, a big concern as self-driving cars become more common. Airline pilots face higher risks of developing cataracts during solar storms, and female crew members see higher rates of miscarriages. In March 1989, a solar storm over Quebec caused a province-wide blackout that lasted 9 hours. A 2017 paper in the Journal of the American Geophysical Union predicted that blackouts caused by severe space weather could impact up to 66% of the U.S. population, with potential economic losses reaching $41.5 billion a day. To prevent such a catastrophe, President Barack Obama's administration laid out a strategy to raise awareness of the dangers of massive solar storms and assess the risks they pose. Last year, President Donald Trump signed the Pro-SWIFT bill into law, aiming to build up technology to improve forecasting and measurement of space weather events. There's debate among scientists about how much we can do to shield vulnerable parts of our infrastructure from solar storms. Using non-magnetic steel in transformers and installing more surge protectors could help, but in the end, better forecasting might be our best defense. A new model developed by the University of Michigan will come online soon to help improve earthbound forecasting. In the UK, National Grid is increasing its supply of spare transformers and conducting regular drills to prepare for a major space weather event. In the past 15 years, the US and UK have built space weather forecasting centers that deliver daily outlooks for airlines, power grids, satellite owners, and anyone else threatened by solar flares. Earthbound observers can see explosive storms erupt on the Sun, but they can't tell the true nature of the threat, how potent it is, until the blast reaches a set of satellites 1 million miles from the planet. At that point, there's only 60 to 90 minutes until it hits Earth. Our ability to understand and predict the solar cycle is still very limited, said William Murta, director of the U.S. Space Weather Prediction Center. Just as utilities prepare for a severe thunderstorm by staging repair workers nearby, similar precautions could be taken ahead of a solar storm, according to Mark Olson, Reliability Assessment Manager for the North America Electric Reliability Corp. "You have the potential for very large areas to have voltage instability," Olson said. "Situational awareness is key here, just like in terrestrial weather events. Solar storms have their roots in an 11-year cycle that shifts the polarity of the Sun's magnetic field. The magnetic forces at work on the Sun get tangled during this process and can punch through the surface, sending the Sun's plasma into outer space and potentially triggering storms on Earth. The most powerful geomagnetic storm ever recorded resulted in the 1859 Carrington event, when telegraph lines electrified, zapping operators and setting offices ablaze in North America and Europe. If a storm of that magnitude were to hit today, it would likely cut power to millions, if not billions, of people. When I first started on this road and was briefed on space weather, I raised an eyebrow," said Prowse. "It's much more mainstream now, and some of the mystification is gone. You can raise it as a risk and not get laughed at." Thanks for tuning in. Don't forget to subscribe to our channel and turn on notifications for more fascinating insights about solar storms and space weather. See you in the next video.